Well, welcome to part 3 of our series on using Monogame, Pygame and Love2D based on this original shoot 'em up tutorial from Kids Can Code. This week we're going to add the collisions and bullets in the same manner as was originally shown. So I'd encourage you to look at this video and get all the basics from it. Today we're going to do that in Love2D and Lua. The code for this is on my GitHub repository here. I think just find the right bit. So it's in episode 3, bullets and collisions, and this is the Love2D section, and these are the files there. So you're very welcome to use those. Right, let's get back to the code. So I'll just fire it up to show you what's actually happening here. It appears on the opposite screen, so I'll just drag that across. So it's running in debug mode at the moment, so everything's quite slow, and it's disabled the detection collision between the player and the mobs. But if I press the space bar, if I press it continuously, we get a stream of bullets, or I can press it once or twice at a time, and then we can kind of line it up. As you can see, detection collision is working fine. We can hit the bullets by getting ourselves lined up underneath them. It's actually harder when it's slower, but there you go. Right, so that's what we're aiming to do today. Let's just shut that off. So the first thing, of course, that we need is a bullet. So this is a new class that we're adding today. So we'll put that in, and I'll just increase the font size. So similar to the mob, we're using the base class which is stored in the library up here, and then we're deriving a new class from that called bullet. We're also including the rectangle object in here so that we can use that, and the shared file which has got some sort of shared variables that we can make use of. So when you make a new bullet here, we're passing in the player so that we can use the player's position to set the position of the new bullet, and then the width and height are being supplied at the moment by the calling code. So we've got the speed being hard coded in at a value of 1000, but if the debug is on, then we're reducing that to 400. And then we're setting the position of the rectangle based on the size and shape of the player's rectangle and the current size of our bullet rectangle. So this is the rectangle collider that's being set up. So using the rectangle object from the class up here. So we've got an X, Y, position, width and height. So let me just go down to the next stage. We've got we can return this rectangle to the calling code if we want to. This is sort of getting the property from it. This is the update function. So every time the update function is called, it updates the position of the bullet, and it's doing it using the speed which we set up here, either 1000 or 400, and then it's going to send it up the screen that way by making it -1 multiplied by the speed. So if we've given it a speed of 1000, making it -1, it's going to go up the screen at by that amount. If it reaches the top, then this flag active is set to false, which is initially set to true, if I remember where. I thought I'd set it up here. That's strange. Anyway, let's put that in. Oh, sorry, here it is. Look, self-active is true. And now we're setting that to false. And that will allow us to either destroy or reposition the bullet as we feel fit. So when this update function is called, it returns the value of self.active. So if it's true, then the bullet continues. If it's false, the bullet is destroyed. And then to draw the bullet, again, we're just drawing a rectangle using the built-in Love graphics rectangle with a filled rectangle here. So that's that one done. We don't need to look into the rectangle class at the moment. Let's go back to main and see how this does its stuff. So when the app starts, let me just increase the font size a bit here. So love.load is the first thing that runs. So this is all as it was before from the last video. We've got these mobs that we're creating, and here we're adding some new code that's defining our bullet as to require the bullet class. We're setting the game state to play, and here we've added a shared.debug is true. Now running it true so that it's easier to demonstrate, so that I can show you things how they're working. If you set that to false, they speed up, and if you are hit by a mob, then the game state is set to quit and you are effectively gone. So the update function here has got some new code in this section here. What we don't want is for you to be able to just continually press the spacebar down and you just get a stream of bullets. We want to reduce the time at which a bullet can be generated. So at the top of the file here we've got some variables. So we've set at the moment a new bullet timer interval to 0.2 seconds. So that will, if you wanted to fire bullets more frequently, then just reduce that to say 0.1. If you want to reduce how many, you could increase it. So if you change that to 1, it would only allow 1 bullet per second, but that's a bit unrealistic. Then we've got a new bullet timer set to 0. So in the update function down here, the first thing that happens is that the new bullet timer, which started off at 0, is increased by delta time, and then when it reaches the amount that we set, which is 0.2 in this function here, so once it gets greater than or equal to the new bullet timer, then it sets this boolean flag allow new bullets to true and resets the timer to 0. So this is used in order to find out whether we can fire a new bullet. So the new code again down here is assuming that we're in the play game state, which we are here. We are now checking to see whether the spacebar is being pressed. So if you've got the spacebar down, then we call this new function called shoot. So if we go up to shoot, there it is. So this one allows you to fire a bullet if enough time has passed. So if this flag allow new bullet is true, which it will be when you very first start the game, and it will be after every 0.2 seconds, then we insert into a table called bullet list, which is an empty table set up here. Bullet list, empty table. Let's go back to shoot. So we insert into that a new bullet by calling the constructor, and we pass in the player and the values 10 and 20. So that's the width of the bullet, that's the height of the bullet, and the player will give it its new position. We then switch the allow new bullet back to false and the bullet timer back to 0, and it won't allow us to shoot again until those two values have been changed back to true for allow new bullet. So that's how the bullet is fired. Now we now need to check a couple of things. Is the bullet going to hit one of the mobs? So that's where we would check that here. And is the player going to be hit by any of the mobs here? We did start on this on the last video, but it's now been expanded to take account of the collisions between them. So if we go back up to the check mob player collisions here, we update the player as before, and then for each mob we're going to go through the list. We update it first, And then we're using this line here to check whether the rectangle made by the player is intersecting with the rectangle made by the mob. If they are intersecting, then depending on whether debug is set to true or false, if the player's been hit by a mob and debug is off, then the game state is set to quit and the game finishes. This allows me to run it in debug mode so that we can ignore any collisions by the mobs hitting the player. Now the new functions that we've got are this one, which is to check the mob bullet collisions here. So this new routine, check mob bullet collisions, has been created. So what it does is it goes through the list of mobs in reverse order, sets a Boolean flag destroy to false, and then has a nested loop which goes through the list of bullets again in reverse order and checks to see whether a bullet is intersecting with a mob, and if it is, then destroy is then set to true, and then from here the mob is reset by calling it set property, so it moves it back to the top of the window so that it is ready to drop down again, but the bullet is removed from the list of bullets. Just as a kind of check, if the number of items left in the list is 0 after you've removed it, then it will break the loop so that it doesn't cause an error. Once that's all been done, then we go back through the list of bullets so that any that haven't been removed because they've hit a mob, we're then checking to see whether they've reached the top of the screen by calling the update function, which actually returns a Boolean true false value depending whether the update has been successful. So the update would not be successful if they're already gone off the top of the screen. Then the active will be set to false, and then it's removed. So that does the checking of the state of the bullets and the mobs. So I think we've covered everything there. Yep, that looks okay. So we'll just run that once more just to go through it again. So we'll bring this into screen. We'll get rid of the console. So we can press the spacebar continuously and get a stream of bullets which is controlled by that bullet timer. We can move as we had before, and each of these, when it reaches the bottom of the window, is reset. It goes back up to the top somewhere around here randomly between the left and right hand sides, and then starts to drop down again. So we're not creating new mobs each time, we're just reusing. So this is a very green program. It's recycling the objects there. So I think that covers everything there, and the next time round we'll be doing using graphics to change instead of these rectangles, but at least the principles of the game are now working. Also, there's one thing I did forget to do, and that is to explain how the rectangle collision is decided. So it occurs twice in this function here, where we're checking to see whether the rectangle that surrounds the bullet intersects with the mob, and again down here where we're checking whether the rectangle from the player intersects with the rectangle by the mob. Now this is done actually inside the rectangle class itself, so we'll just increase the font on that one. So this is inside the library here, so this is the rectangle class has already been created. So we've kind of looked, I think, briefly into it once before, where when you create a new rectangle, you give it the x and y coordinates, width and height. And then we've got this inbuilt function, rectangle intersects, which is where it's used in the routines that I just showed you. And what this does is it checks its own rectangle with whatever rectangle you are passing into it. So if this rectangle is part of the player's own rectangle, it will use that to check it against the mob that you pass. So we're comparing two rectangles, of which one of them is the self rectangle, whereas the other one is the foreign one, the other body that we're looking at. So it's relatively simple maths. We're just checking, first of all, whether width and height have been, for some reason, not set. And if they're nil, then we give them the default width and height there. Then on these ones here, we're checking whether the rectangle belonging to the object, let's say we're checking the player against a mob, so self.x would be the player's x coordinate, and the mob's rectangle would be rect.x. So if we add its x coordinate and its width, and then also at the same time check whether it's greater than this other functions here, which is the width of the self rectangle. So if those are true, then we return false. And if we've got a similar thing with the y coordinate here, so it explains it in these comments just here. So what we're checking initially is the left side of the rectangle beyond the right side of the other rectangle, and if it is, then there's no way they can be intersecting. Or if the left side of the second rectangle is beyond the right side of the first. So that's what this code here is doing. And in a similar fashion, we're checking the tops and bottoms of the two rectangles as well. So if they are if it's not possible for them to be intersecting, then we can submit false straight away. But if both of these checks fail, then we must be intersecting, and it returns true. So it's a relatively simple procedure, but it does the job beautifully. So that's inside the rectangle class, and so the great thing about that is that we can call it wherever we use a rectangle. So it's in the bullet, it's in the player, and it's in the mobs. The rectangles are all in there, so we're using the same classes all the time. So that's quite useful to get that ability. The other things in here is that we can return the entire rectangle. We can also get the center of the rectangle spelt in both English UK and English US, so that those who prefer one value way of doing it can get the same properties out of it. And then we've got an update on the rectangle and an update position. So these are the two functions that you can call when you're updating it, depending whether you wanted to update just its position or the whole thing.